So we'll go start from question 15 here, and a stone is thrown vertically upwards with an initial velocity of 40 meters per second, taking g to be 10 meters per second squared. Find the maximum height reached by the stone. What is the net displacement and the total distance covered by the stone? So the stone is thrown vertically upwards, so which means that initial velocity is 40 meters per second, and at the maximum height, right, its final velocities will be 0, right? That's when it will change the direction. So v will be 0, and we know that the acceleration due to gravity is 10 meters per second in the opposite direction, which means that it has to be minus 10 upwards. So with this, when you can apply the third equation of motion, which is 2as is equal to v squared minus u squared, and when you apply this, you will find that the distance covered by this object is 80 meters, right, one way from the bottom till the maximum height. So the total distance has to be 2 times 80 because it goes 80 meters up and 80 meters down, so it has to be 160 meters. What is the displacement? We understood that the displacement is the net distance covered, right? So in this case, the object comes back to the same place, so the net distance is 0, right? So the displacement is 0. Calculate the force of gravitation between the Earth and the Sun. Given the mass of the Earth to be 6 times 10 power 24 kgs and that of Sun is 2 times 10 power 30 kgs. The average distance between the two is 1.5 times 10 power 11 meters. So let's between the Earth and the Sun. Okay, so let's consider the mass of the Earth to be me, mass of the Sun to be ms, the distance between them to be d. So we can apply the Newton's law of gravitation, which is F is equal to g, gravitational constant g times me ms over d squared. So when you substitute all these values, you're going to get something around 3.6 times 10 power 22 kg meters per second squared. So this is going to be the gravitational force. This is going to be the force of gravitation between the Earth and the Sun. Okay. Question 17. A stone is allowed to fall from a tower 100 meters high, and at the same time another stone is projected vertically upwards from the ground with a velocity of 25 meters per second. Calculate when and where the two stones will meet. Okay. So let's consider this way. So this is the tower, which is 100 meters tall, and this is the first stone that is being dropped, and this is the second stone that is being thrown from the bottom. Let's assume that they are meeting at this point here, right? And the distance covered by the first stone, let's call it SA, and the distance covered by the second stone, let's call it SB. So we know that SA plus SB equals 100 because the total height of that tower is 100 meters, right? So we know that SA is equal to UT. We know that the distance covered by this is equal to UT plus half GT square, and we know the original velocity of the first stone was 0, right? Because it was just dropped from here. So U for the first stone is going to be 0. So this part will be 0. And we know that G is 9.8 because it's the acceleration due to Earth's gravity. So this gets you SA to be 4.9 t square. Let's keep it here, and let's consider let's apply the same logic, same formula for SB. SB is equal to again UT plus half AT square. The only difference is that in this case U is 25 meters per second. It was not 0. And your G has to be minus 9.8 because it is in the opposite direction. It is going upwards. So when you apply this, you will find that SB equals to 25t minus 4.9 t square. And you know what this one is. 4.9 t square is SA. So with this, you can equate SA plus SB equals 25t. So t equals 100 by 25, which is 4 seconds. So it takes 4 seconds for them to meet here, right? It's after 4 seconds that the first stone and the second stone will actually meet. So calculate when and where. So we have now we found out when it is going to be 4 seconds. So where we have to find solve for one of this, whether SA or SB, right? So SA is equal to 4.9 into 16. right? That is this formula. So which means that, SA comes down to be 78.4 meters from the top. So both the stones meet at 4 seconds after the first stone travels, 78.4 meters from the top. Question 18. A ball thrown up vertically returns to the thrower after 6 seconds. Find the velocity with which it was thrown up, the maximum height it reaches, and its position after 4 seconds. So, so we know that we know that if the ball is thrown, it has taken 6 seconds, which means that it has taken 3 seconds to reach the top and 3 seconds to reach to come back, right? So with that, let's calculate each of this. The velocity with which it was thrown up. So we are looking for the initial velocity, which is u, which we will derive, and we know that the final velocity is 0 after 3 seconds, because it would have it would have come. It would have reached the maximum height before it was falling, right? So and a is equal to minus 9.8 meters per second square, because it is negative because of it's going up. And we know that t is equal to 3 seconds. So with this, you can apply the first law of motion of u is v is equal to u plus at, and with that you know that so this v is equal to u plus at, and with that you know that u is going to be 3 times your acceleration due to Earth's gravity, which is 29.4 meters per second. Now the maximum height it reached. So this is the initial velocity. It was thrown with this speed, 29.4 meters per second. Now with this, you can apply the third law of motion to find the maximum height it reaches, which is s, right? So you can solve for s by this formula, and when you apply for this, you will see that it is going to be approximately 44.1 meters. Now for the third one, its position after 4th second is, we know that it would have taken 3 seconds to reach the maximum height. So it is after 4 seconds, it's just enough that we find the distance covered by that object in the first second after it has reached the top, right? So it's enough that we find that. So when it has reached the top, we know that its initial velocity is u is 0. And all what we need to know is that how much time, how much distance did it cover after 1 second, right? After reaching the top. So we just need to solve for s, and s equals ut plus half gt square, and u is equal to 0, and we know t is also equal to 1, and we know g is equal to 9.8. So with this we can figure out that it comes down to be 4.9 meters from the maximum height. So that is the position of the ball after 4 seconds. In which direction does the buoyant force of an object immersed in a liquid act? We know that the buoyant force always acts perpendicular to the object, right? It's the upward force, right? Why does a block of plastic released under water? Why does a block of plastic released under water come up to the surface of the water? That's possibly because the density of the plastic is less than the density of the water, and that's what we learned earlier, right? And the weight exerted by the plastic, and because the density is less, the weight exerted by the plastic is balanced by the buoyant force, right? So that's why it doesn't come in. 21. The volume of 50 grams of a substance is 20 centimeter cube. If the density of water is 1 gram per centimeter cube, what is will the substance float or sink? Okay. So we know the density of the water to be 1 grams per second cube. For the object to actually sink, the density of that object should be more than the density of the fluid. So the density of the object should be, if the density of the object is more than 1 grams per centimeter cube, it will sink, right? Because the buoyant force will be less than the weight of that object, right? So let's calculate the density of the substance. So the density of the substance is mass over volume. The mass is 50 grams and the volume is 20 centimeter cube, so which is 2.5 grams per centimeter cube. So this is clearly more than the density of water, which means the object is heavier than water and it will sink. Last question. The volume of a 500 gram sealed packet is 350 centimeter cube. Will the packet float or sink in water if the volume of if the density of the water is 1 gram per centimeter cube? What will be the mass of the water displaced by the packet? Okay. So first question is, the first question is, will the packet float or sink? Right. So for this we need to find out the density of the sealed packet. Right. The density of the sealed packet. If the density of the sealed packet is more than 1 gram per second cube, it means it will sink. So we know that the density of the packet is equal to mass over volume. We know that the mass is 500 grams and the volume is 350 grams. So it is 500 over 350, which is equal to 10.7, which is equal to 1.5 grams per centimeter cube, which is more than the density of water. So it will sink. The sealed packet will sink. Now, what will be the mass of the water displaced by the packet? So we know that the mass of the displaced water, right? The mass of the displaced water, per Archimedes principle, we know that the mass of the displaced water can be calculated from the volume of the object, right? So in this case, the volume of the sealed packet is 350, right? 350 centimeter cube. So that is the volume of the sealed packet, and it is that volume of water that will be displaced, right? So, and how do you find the mass of that water that is displaced? That is the density of the water times the volume of the object, right? Volume of the object that was immersed. So in this case, the density of the water is 1 times the volume of the object that had completely immersed. Because it has sunk, it is a complete volume, which we know it is 350 centimeters cube. So it is 1 times 350, which is equal to 350 grams. So 350 grams is the mass of the water that will be displayed by this object that has completely sunk inside the water. So this comes, with this we come to the end of, the gravitation chapter, and we'll look forward to seeing you in the next chapter, which is work and energy. Thank you.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share and subscribe this with your friends. Thank you.